Section 11.4 has to do with the surface area of prisms and cylinders. The surface area is basically the sum of all of the sides. So if you could take like a cube, here's a three-dimensional cube, and you could draw it out flat, you would see that this, if you unfold it and you fold it along these fold marks, this would have that cube shape. So I would fold this up, this would be your top, and those would be your two sides. So if I'm talking about the surface area, I'm talking about finding the area of each of those things and adding it together. So the area of this, 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 and this, this, and this. And adding them all together as if like I was going to paint all of the sides of this. This is different than the volume. The volume is what's inside it. The surface area is the whole surface on the outside. And this is what we call a net drawing of that three-dimensional figure. So if I was going to find the surface area of this three-dimensional figure, I would need to find the area of all of its sides, and then I would add all of the sides together. So I'm going to see if you can follow this. Okay, if I put this there. Now obviously this is not a square. I'm looking for, I don't really have one that's similar to that. But on the bottom, remember, the area of a quadrilateral is base times height. So I have 20 times 14, which is going to give me 280. And I actually will allow you to use a calculator for this. So the bottom is 280 inches squared, which is going to be the same thing the top is. So the bottom, the top, they both have the same value, which is 280 inches squared. 280 inches squared. Then I have this side right here, which is going to have the same value as the side opposite it. So I have 14 times 10. So this side and this back side, okay, so I'm going to call this the right, let's call it the right and the left. Right side, left side. So the right side would be 140 inches squared. The left side would also be 140 inches squared because it has the same measurement. Now the only thing you have left is the front and the back. Now if this is 10 inches high here, then this one right here is also 10 inches. So the front and the back, you're going to have 10 times 20, which is going to be 200 inches squared. 200 inches squared. So to find the total surface area, I would add that all together. So I have 280 plus 280 plus 140 plus 140 plus 200 plus 200, and that is going to give me 1,240 inches squared. And that's going to be your total surface area of that. And it's not really a cube, but it would be, basically it would be a rectangular prism. Okay, so here's another that I need to find the surface area of. Across the bottom, let's see, do I have one? This one's probably more similar to that. So if you will, this is 21 inches, this is 34 inches, and then this is 4 inches high. So I have the top and the bottom, this and this, that would have the same. I have the front, let's call this the right side and the left side, right and left. And then I would have a front and a back. Okay, so those are my 6 sides. Okay, so the top, this is going to be a 21 by 34, so that's the top and the bottom. So I'm going to take my calculator and I'm going to go 21 times 34, which is going to give me 714 centimeters squared. 714 centimeters squared. Then I have a right and a left, which is 4 centimeters by 34. So 34 times 4 is going to give me 136 centimeters squared. So that's going to be the right and the left. And then the front is going to be this, and the back would be back there that you can't see. And that's going to be 21 times 4. Which is going to give me an 84. So that's an 84 on the front and an 84 on the back. Now all I have to do is add that together. 714 plus 714 plus 136 plus 136 plus 84 plus 84 is going to give me 1,868 centimeters squared. All right, now I've got the surface area of a triangular prism. So remember, I've got a triangle and a triangle, so I have my two bases. Then I would have this surface, the bottom surface, and the back surface. So I've got a front triangle, back triangle, right side, left side, or well, let's call that the back side, and the bottom. Okay, so those are all the different sides that I have represented. This one is a little bit like this, I think. Let's see, do I have one that's closer? This one might be closer to that. Okay, so I've got this well, no, let's do this one. Okay, so I have a triangle on the front and the back. I have this front side, I have this back side, and I have a bottom underneath that. Hopefully you can see that. Okay, so remember, on a triangle, it's 1/2 the base times the height. So the base is 3, the height is 4, so 3 times 4 is 12. Half of that is 6. So I have 6 centimeters squared, 6 centimeters squared. And then I have the right side, and that's a rectangle that's 6 times 5. So that would be 30 centimeters squared. The back side is a rectangle that is 6 centimeters, and then this is, 4 centimeters, and this is 6 centimeters. So that would be 24 centimeters. And then I have the bottom, which is 3 centimeters times 6 centimeters, which is going to be 18 centimeters. And then I just add it all together. So I have 6 plus 6 plus 30 plus 24 plus 18 is going to give me 84 centimeters squared. And that's going to be the surface area of that triangular prism. Here's another one. Okay, again, I've got my two bases, which are triangles. So front triangle. It really helps if you'll list everything out. Back triangle. The bottom here. And then I have the front, or the top right, and the top left, which would be the back of that. Looking to see whether I have something similar to that. Maybe sort of, well, it's not a right though. It's kind of like this, that I have the two sides. I have the bottom, I have the back, and I have the front. Or if it's looked like this, you've got front, back, bottom, right, top right, and top left. Okay, so the front, I have a 16 here, because if this is 16, this is also 16. So I have 12 times 16, that's the base and the height, and then I have to take half of it, divided by 2. So each of the triangles are 96 meters squared. The bottom is a rectangle that's 20 by 3, so that's going to be a 60 meters squared. And then I have this rectangle here, which is a 16 times 3, which is going to be 48 meters squared. And then I have this one that's in the back. Now notice this is 3 meters across here, because that's the same as that. So I have 20 times 3, which is 36 meters squared. Then I have to add them all together. So I have 96 plus 96 plus 60 plus 48 plus 36 is going to give me 336 meters squared. Okay. Now let's move to a cylinder. I can do the net drawing of the cylinder and understand that if I unwind it, I'm going to get a circle, and I'm going to get a circle. If you will, if I take a piece of paper and I roll that piece of paper, okay, it's going to give me a shape of a cylinder, okay? And at the top of it is round, and the bottom of it is round. But then when I unroll it, I get a rectangle, or I get like this, the piece of paper. So if I were to cut it right here and unroll it, I would have 2 circles, and I would have a rectangle. The length of the rectangle would be the same as the length around the circle, or the circumference of the circle. So the formula for finding the surface area would be 2 times pi times r squared, which would be the area of this circle and the area of that circle. And then it would be the length of this, which is 2, it should be 2 pi r times h. Okay, so this right here should have been 2 times pi times r times h. This right here is your circumference of the circle times the height. Okay, so let's do one of those. All right, so if we are finding the surface area, I want to find the 2 bases first. So I've got, this is going to be, remember the area of a circle is pi r squared. R here is 1, so 1 squared is 1. So I'm going to have 2 times 3.14, because that's going to be the area of this space and the area of this space, plus the circumference, which is 2 times pi times r, which in this case is 1, times the height, which here is 3. So I have 6.28 plus, and that's going to be 3 times 1 times 2, which is going to be 6 pi, and you can use your calculator on this. Remember, there's a pi button on your calculator. So you have 6.28 plus 2 times, use your pi button, and you're going to get 25.13, and it's going to be meters squared. Okay, so this is your area of your 2 circles, and this is your area of this rectangle unfolded, because this is the circumference of the circle times the height. You're just following that formula. Remember, the formula is going to be 2 times pi r squared plus 2 pi r times h. Circumference times height, 2 times the area of the circle. All right, so here we have, let me throw in a 2 right here. I don't think I put that in there. So again, I'm following the formula. 2 times pi, the r is 2.5, so that's going to be squared, plus the circumference is 2 times pi times 2.5, there's my r, times my height, which is 8. So I take my calculator and I go 2 times parenthesis, I hit the pi button, I hit times 2.5, and that's going to give me a 39 point, we'll call it 3 there, and I've got to do all that on my calculator. 2 times pi times 2.5 times 8 is going to give me 125.7. So I'm going to add those together. I'm going to get the total surface area of this cylinder is 164.96 meters squared. Now your cylinder, is going to be the area of the top and the bottom, and then the area of the side, which is going to be the circumference times the height. Again, you're following that formula. All right, your homework on this is page 576, 9 through 18 all. Hopefully, I'm trying to get that into focus there. There it goes. Page 576, 9 through 18 all.